Okay. So my background is computer science, applied geophysics, signal analysis, volcano seismology. So I'm not an expert in satellites. But of course, my task is to promote, the collaboration in any scientific field. So we organize events covering all science and also humanistic. Yeah? You will, pardon me if, in some cases I will not be, too much expert in the specific area. So I will try to do my best. Actually, so I normally do, let's say, deal with universities and research centers, let's say at the researcher level. Let's say, very close to the embassy, there is also Unitalia that is promoting the exchange of students. So I know that there are students in the room. So this person that you see on the back is Romero Sinaga, that he's the responsible of Unitalia. So if you, after this workshop, you will feel like, okay, I want to continue my study in Italy, studying these subjects, you can contact him and get information about that. So now we start with our agenda. So I now give the floor to Dr. Maria Battaglia, the director of Istituto Italiano di Cultura, for an official welcome to this very nice place. Thank you.
Dai, stiamo insieme. Thank you, Roberto. I am very pleased to host this edition of the Italian National Space Day. This is Cultural Center of Embassy of Italy, and also to promote Italian culture and Italian language. I would like to invite you to explore, to visit this exhibition after this meeting about sport. Title is Over the Limits, and this section named Love. Love would like to explore the deep connection Italians have with the sport. I wish you a good meeting, interesting meeting, and enjoy. Thank you so much.
Thank you very much, Maria. Actually, you may wonder, why we put, these two things. Actually, one of the questions online was exactly that. What has to do sport with space? Of course, the links between Italy and Indonesia are, they cover everything. So, of course, this exhibition is here. Actually, the other day was there was the inauguration here, and we are in this room. So, not now, but later when we have also something to drink and eat, you can, go around and look at this exhibition, which is also very interesting. So now I give the floor to Dr. Giovanni Finarelli Baldassarre, the head of the Economic Commercial section of the Embassy of Italy.
Thank you, Professore. Thank you very much. I'm here also not only as head of the economic section, otherwise I will be a bit outside my environment, obviously, but also as chargé d'affaires, since the ambassador is outside the country. So let me just thank you very much. Allow me to thank you for attending this event of great importance for us, since talking about science, technology, innovation, allow us to highlight a central feature of Italy that is often less known to the public. From the beginning of space exploration, Italy and its enterprises played a central role in space research and space economy. We are proud to see our technologies pushing the boundaries of this discipline, guiding us on a remarkable journey to explore the universe and to see Earth from a fresh and inspiring vantage point from above. In this regard, allow me to thank Dr. Roberto Gigotti and Dr. Nina Mirkovic from e-GEOS, Leonardo Group, that are joining us online. and Dr. Mario Edoardo Simmaco, CEO of Green Ant, also connected online. I'm sure that the insights that they will share with us today will deepen our understanding of the innovative solutions developed by Italian companies operating in the space sector. Allow me also to thank the distinguished Indonesian guests that join us today here in person, Professor Erlan Darmawan from Universitas Gadjah Mada, Master Engineer Erlangga Ibrahim Fattah from ITERA Lampung, and Dr. Iqbal Putut Ash Siddiq from Universitas Indonesia. They will help us to understand the Indonesian position towards space, the ambition, the goals, and the opportunities offered by this immense country positioned in a very strategic position, close to the equator, in the middle between the Indian and Pacific Ocean. So located in a strategic position and enriched by so many universities and research centers that are launching Indonesia in the space sector, literally. Last but not least, allow me to thank Professor Roberto Carniel. Professor Roberto Carniel, Scientific Attaché of the Italian Embassy, for the amazing job done in organizing this event, and Dr. Maria Battaglia, Ibu Battaglia, that is hosting us once again in her beautiful Istituto di Cultura that offers us also an amazing exposition about Italian sport. Dear participants, it is a pleasure to welcome you to the Italian National Space Day. This occasion allows us to reflect not only on Italy's long-standing commitment to space exploration, but also on how space technologies have become an essential component of modern economic development. Italy has invested consistently in this vision since the launch of San Marco 1 in 1964, and that commitment continues today, also within the European Copernicus satellites program. The recent launch of Sentinel-1D is an excellent example of this trajectory. Italian industry plays a central role in this mission. Thales Alenia Space is the prime contractor of the entire series of Sentinel-1 satellites on behalf of the European Space Agency. Leonardo provides us critical instruments and sensor, and e-GEOS ensure us that Copernicus data can be transferred into services that support institutions and businesses around the world, including, of course, in Indonesia. These capabilities do not remain abstract. They translate into real services. They support sectors that are strategic for Italy and Indonesia, such as precision agriculture, maritime security, infrastructure monitoring, insurance, climate adaptation, and emergency response. Reliable satellite data reduce costs, increase planning accuracy, and mitigate risks that affect heavily both the private and the public sector. These applications are already active, but there is room to expand them further through Italian-Indonesian cooperation. This workshop, therefore, is not only a scientific meeting. It is also an opportunity to connect universities, research institutions, space companies, public authorities, and emerging startups. By strengthening this connection, we can use satellite data as a driver of innovation, competitiveness, and sustainable development. I wish once again to warmly thank all the speakers, both online and here in the room with us, and all the participants that have dedicated an afternoon to learn, think, and discuss about space economy. I am sure this workshop will open new perspectives for collaboration, bringing together Indonesian and Italian expertise and needs to benefit of both sides. Thank you very much. Terima kasih banyak.
Thank you very much, Giovanni. So as a scientific attaché, for me it's really a pleasure to introduce the scientific session of this workshop. So after the words that we spent until now, we go to the, let's say, to the real team. As I was saying, let's say, favor the collaboration in any scientific field. For example, the last event that we organized here was last May, I think. It was on sustainable coffee, for example. So we really cover, you know, all the fields, so very different. So today we celebrate la Giornata Nazionale dello Spazio in Italiano. And of course, in particular, to better understand and mitigate natural hazards. And the scientific relevance of this field has increased dramatically in the recent years, also due to, you know, climate change, etc. But also, you know, driven by advances in sensor technology, data processing, European programs such as Copernicus, which we will, you know, hear a lot about that today, which has actually the additional benefit of a policy which is full, free, and open access. So data are distributed globally without direct costs, subject only to standard online registration and terms of use. So you will see later the applications that were done here in Indonesia using this data. So Copernicus represents the world's largest Earth observation system at the time. So its Sentinel satellites can be grouped in families that are designed as complementary tools. So each provides a different window into the dynamics of the planet. So just for today's discussion, it's useful to just briefly recall at least the basics. Although I think that you know, the speakers later will give you a deeper description of the data they use. Yeah. So we have Sentinel-1, the family of Sentinel-1, which is an all-weather radar imaging, and it's very important that it is all-weather because radar can go through clouds, so you can see let's say the landscape and the land and the sea, even if there is if it is cloudy, which in Indonesia is not so uncommon. You would agree. So the instrument delivers spatial resolution up to 5 meters with swath widths up to 400 kilometers. There are in the constellation 4 satellites, and last one, Sentinel-1D, was just launched 1 month ago on 4 November 2025. And if you go on the web, you can already see the first images coming from this satellite, which is actually already working. And this family, like almost all the other families, I will name an exception, let's say cover all the globe. So both Italy and Indonesia. For the case of Sentinel-1, it's coverage every 5 to 6 days. Sentinel-2 is another family which is based on optical multispectral imaging. So as I was saying, they are all complementary to each other. So they see the same thing in different ways. So it's an optical mission, so it's multispectral imagery at different wavelengths, with also different spatial resolutions from 10, 20, 60 meters, depending on the spectral band. And it covers actually 13 different bands, but as it is, let's say, optical, it cannot go through clouds. So you see that you get different information and maybe not all the time like the one of the radar. Also in this case, you cover all the world, so with at this, let's say, close to the equator, the revisit cycle, I think, is about 5 days. And it is more frequent at higher latitudes, depending on, you know, on the trajectory of the satellite. But we can say that both Italy and Indonesia are constantly covered by this satellite. Then we have Sentinel-3, which is ocean and land observation. So it has the sea and land surface temperature radiometer, so it can measure the temperatures on the ground and on the sea. We have also on the same satellite the ocean and land color imager. You have to imagine that in every satellite there are multiple sensors, so you can get different information. And actually the satellites can also host, for example, sensors from third parties also. There is an altimeter, SAR altimeter, so that can measure sea surface height. Okay, so we can measure, of course, not at because one of the questions, for example, of the online was how this can look at the propagation of tsunami. The resolution is not enough. You know, of course, for tsunami, we have other tools that are much more efficient, you know, on the ground. Yeah? Then there is Sentinel-4. Sentinel-4 is a bit of an exception because it's actually a geostationary satellite, which means that it always stays in the same place, which is over Europe and part of Africa. So it can only cover that part of the world. So it cannot cover at all Indonesia. Okay, so this is the only one. And it is, let's say, dedicated to measuring the atmospheric composition. Then there is the family of Sentinel-5 and Sentinel-5 precursor, which measure, let's say, the parameters of the troposphere. Again, you have different, let's say, frequency of cover, but still it can cover Italy and Indonesia continuously. And then there is also some new upcoming Sentinel-5, which will provide also trace gas and aerosol measurements with kilometer scale footprints. So it will be used again to get, you know, monitoring service of the atmosphere. And finally, we have Sentinel-6, which is high precision altimetry, which is also used to measure sea surface height. So the changes in, you know that also with climate change, unfortunately, the sea is changing its height. So we can measure and monitor these changes. Yeah? Again, it covers the Mediterranean, but it covers also the sea around Indonesia. I want to stress again the data policy, which is full, free, and open access. So you have to register. Maybe you can actually ask information to them because they demonstrate that they can use, you know, the data. Yeah. Did you pay for it? No. Okay. So that's the most important thing. So if you want to use the data and you have ideas, you can use the data for free. Okay. So Indonesia, of course, is a natural laboratory, yeah, because it has, I always say that apart from snow avalanches, it has all the natural risk that you can imagine. Yeah, so, but of course it has also, you know, exposed coastal zones. You have extreme geological activity, a lot of volcanoes. You have rapid urban expansion. You have Jakarta that is sinking. So you have, of course, you have climate-related pressures, okay? All of these are all observable by satellite, yeah? So Sentinel-1 and 2 provide frequent acquisitions, depending on the constellation phase, of course. And you can also get deformation fields. We will look at that today. Thermal anomalies, atmospheric measurements, high resolution data. So why Italy is important for this? Because Italy is one of the, let's say, important contributors to the development of these satellites. Of course, they are European satellites, but we already said that many, let's say, Italian companies, although they are state-owned companies, yeah, are working, you know, to develop this satellite. And of course, also Italy is, you know, has a lot of researchers doing research on these fields. So again, you know, I strongly invite you, you know, to contact maybe through me to put you in contact with Italian research groups working on this field or on your field or a complementary field. And today, speaker, we will have people connecting from Italy that will actually from e-GEOS, which is or e-GEOS, which is the company that actually receives the data and shares the data. We will have also another online contribution from maybe you can already put the slide with the faces of the speakers. So we will have also Dr. Mario Simaco that is is the head of the Green Ant which is a private company that is working using heavily satellite data. And then, as we were saying, we have 3 Indonesian researchers, Professor Helan Elmawan, Engineer Erlangga Ibrahim Fatah, and Dr. Iqbal Putut Ash Shidik, from 3 different universities in Indonesia that actually use this data for their research. So I think we are ready for a scientific session that will begin shortly, but before I forget, actually, let's now share a photo session, because you know that in Indonesia nothing happens if there is no picture of it. Yeah. Okay. So I invite the speakers here, and of course Dr. Finarelli and Dr. Maria Battaglia. Maybe can you? Yeah. 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 Now we have to find a way to get a nice. We wait for the director. And you can see online also our other speakers. So now we are ready to go into the real thing, okay? And I want to invite Dr. Roberto Gigotti from e-GEOS company. Are you there? Are you connected?
Yes, I am. Good afternoon, everybody. Can you hear me?
Yes, we can hear you. We do not see you yet, but now you will be on screen, I think. Can you put the...
Okay.
Yeah.
So good afternoon, everybody. Thanks to Professor Roberto Candiano for the organization and for inviting us to this important session. I will make a very short introduction about our company e-GEOS and then leave the floor to my colleague Nina Milkovic, who is going to present the content of one of our services and capabilities we have. So I try to share the screen. Let me see if it's possible to do that. Okay. I don't know if you can see my screen. Can you see my screen? Hello?
They say you did not share.
I can.
Okay, now I think something's changing. Okay, now
Can
we
you see
see.
my?
Thank you.
Okay, great. Okay, so as I said, a short introduction about our company, e-GEOS. We are a company based in Italy, of course, since operating since more than 15 years. And we have been founded 15 years ago from Telespazio, which is a very important actor in Italy for the space business since more than 60 years, and Italian Space Agency. 80% of our company is owned by Telespazio and 20% owned directly by Italian Space Agency. And inside our group, inside our company, we have a team of more than 600 people working exclusively dedicated to the geoinformation business, which will be described later. As a matter of fact, Telespazio, ourselves and Telespazio, we are part of the Leonardo group, and in particular, we are part of the space division of Leonardo, which has been recently founded, established by the end of last year, beginning of this year. And this division is comprehensively providing product and services for the whole value chain of the space business. So putting together all the capabilities of the group, including Telespazio, Thales Alenia Space, Leonardo itself, and e-GEOS, the space division is able to provide any kind of product and infrastructure for the so-called upstream or space segment. So anything which is related to the construction of satellite or any other space capability in the upstream sector for a variety of missions from telecommunication, geolocalization, and Earth observation, and in general the space exploration. The space division is also dedicated to so-called midstream, so whatever it is necessary on the ground, so-called the ground infrastructure to manage the space mission, the satellite mission, so the construction of ground segment and infrastructure on the ground. And then the third piece of the product and services is dedicated to the so-called downstream, which basically is the capability and the necessary infrastructure and networks and platforms necessary to provide services and product to the users, to disseminate the product and services realized using the space and ground infrastructure. So the combination of all this capability makes the space division of Leonardo cover the entire value chain of this business. And e-GEOS, as you can see from these slides, we had in the downstream sector, specifically to the geoinformation, which is one piece of this business. What we do, we provide data, satellite data, and realize the infrastructure to receive satellite data from space. We developed product and content. We extract information and analytics from the satellite images and using also other kind of satellite data. And then we realize the digital platform services and application for the users, putting together the satellite images with other kind of data in order to provide the end user services necessary for the various vertical market. We serve both the civilian and defense business worldwide level, in Italy, in Europe, and worldwide. And actually, we have a long-lasting collaboration with the Ministry of Marine Affairs and Fisheries in Indonesia, KKP, since a lot of years, and my colleague Claudio Serafini, connected here, is responsible for this activity since more than 10 years. So we have established a capability in Indonesia, especially dedicated to the marine monitoring. Going a little bit into the details of what we do, in terms of satellite data, we have exclusive distributor of a constellation called Cosmos Skymed, which is probably the most advanced radar constellation today available in the market, owned by Italian Space Agency and Ministry of Defense of Italy. It's a constellation available in the market since almost 15 years now, composed of 2 generations of satellite, the first generation and the second generation. Today, there are 4 satellites up and running in the space, assuring a coverage twice per day everywhere in the world, in every location in the world, with a lot of capabilities in terms of different acquisition mode from the very, very high resolution data up to 50 centimeter to the strip map mode for the middle resolution and the scansar mode for the low resolution with a wide size of image capability. So it's a comprehensive constellation and SAR mission. Very, very high quality of data. And again, we have the exclusive distributor worldwide serving both civilian and defense customers. On top of that, we also distribute and use in our digital platforms several other kinds of satellite mission data, both in the optical and radar domain, and relatively recently also in RF data, radio frequency data, and IS data. These are the type of information very useful for the different vertical market segment that we serve. As I was introducing initially, the ultimate scope of our product and services is to serve different market segments and different applications depending on the user needs. Because of that, we have made a huge investment several years ago to develop digital platforms, digital software platform that we provide either in terms of services. So by using this platform on our premises, we deliver product and services to our customer, or we can also deliver the platform on premise to the customer base, customer premise, exactly. And in order to realize what we call the Geo-Information Center and give the customer the capability to realize product and services on their own. The platforms that we are developing are dedicated to different market segments. We have a platform called Sea-on-Sea, which has been developed to serve the maritime domain, from basically provide what it is called maritime domain awareness, maritime surveillance for both civilian and defense application. So running from the environmental protection needs, like management, detection of oil spill, and detection of anything related to the environmental protection needs, to other kinds of monitoring specifically linked to the vessel detection, which helps a lot both the law enforcement and the defense users. We have a specific platform dedicated to the image intelligence for defense field, which is called the BRAIN. It's a platform which incorporates our capability to analyze very, very high resolution data, providing intelligence information to the defense users. We have a platform called e-GEOS to support the agribusiness. As you probably know, this is a kind of business increasing a lot the importance of monitoring the crop and the culture from satellite, and by using satellite data, a lot of insight can be provided to the either governmental organization or the company exploiting the product into the field. We have this dedicated platform to support this business. Then we have another platform called Aware, which is based on again, several technologies using radar and optical data dedicated to monitoring of critical infrastructure. Critical infrastructure, highway and railway, or in general urban installation. So by providing a capability of change detection and INSAR monitoring ground motion, which can be very relevant, especially in sites like Jakarta, as Professor mentioned. So it's a dedicated platform to provide very, very detailed information on the field. And finally, we have a comprehensive capability in terms of digital technology, software, and procedure that we put under the umbrella of MAPSI, which will be described in detail by my colleague Nina later. It includes all the capability we have in producing a mapping from satellite data, satellite images, and in particular satellite mapping in an emergency mode, in very rapid mode, supporting the emergency situation. Just to conclude my introduction, of course, we have a very strong and well-proved capability to provide a training and capacity building program. As I was saying, we have realizing a lot of infrastructure on customer premises, and these are normally integrated with capacity and building and training program to make sure that the local team is able to exploit and to realize the product and services by their own. So we put in place our long-lasting capabilities and expertise in this sector by providing training and capacity building program. So with that, I have concluded my introduction and give the floor to Professor Kandian, and I don't know, maybe if there are some questions, I don't know how it is organized, the Q&A session, either now or later at the end of the program.
Thank you very much, Roberto. It was a pleasure also to see you in face-to-face, like because we exchanged emails, but we never met. So is there any quick question now? Because of course, later we will have a question and answer session, but if you have something that you feel urgent to ask now, you can. No? Okay, so I think we can proceed to the next speaker, which is still from e-GEOS, Leonardo Group, Dr. Nina Mirkovic, that will speak about Copernicus emergency mapping service, when every minute counts.
Let me know when you can see my screen.
Yeah, now, not yet. Okay, yeah. So I leave you the floor. Thank you very much, Nina.
Thank you all for organizing this amazing event, and thank you to my colleague Roberto for a very nice and in-depth introduction of our company. I'm going to present the Copernicus Emergency Mapping Service, when every minute counts, as it was anticipated by my colleague. This is a service during emergency situations, and we provide the management based on remote sensing products. As you can see here, the service capabilities are 24/7, 365 days a year, and e-GEOS is the leader of the project since the beginning, plays a key role in the provision of geoinformation products to support civil protection and humanitarian aid operators during natural and man-made disasters. Through Emergency Response Coordination Center in Brussels, that validates the request for service, the users are European countries, other participating European countries, national authorities inside or outside of the Europe, and other international organizations such as the World Bank or offices of United Nations, responsible for managing civil security related aspects during the crisis. The project has more than 100 experienced operators that were involved in all of the 850, now more, we are at 852 activations for the emergency management service. Within these 850 activations, we have provided more than 9,000 maps. And you will see later on the products, what they are based on. We use all multi-mission sensors that we can, and collaborating with ESA, we have a lot of contributing missions. We have provided products for more than 100 countries so far. The disaster triggering is based on the disastrous event. So it can be floodings or fires or storms, cyclones, but also concert or COVID situations that as we had a couple of years ago, right? As well as volcano eruptions and earthquakes. What is important for the service is to know, is the event ongoing? So is the fire extinguished, or it's still ongoing, to give it proper priority and proper analysis workflow. This is a brief overview of the workflow itself. So from the moment that the service gets activated through an online form that gets automatically transcribed to our platform, we have a tight schedule of maximum 2 hours to plan satellite imagery. In parallel, we are searching for available data, so already available satellite imagery, and we are producing the pre-event analysis, so the situation before the event, right? Then, upon receiving the first imagery, we provide different kinds of products with different time frames. This is the portal you can find online. You can see down below the link. And there's the page also to submit the service request form. The product type definition is based obviously on the type of the event itself. We produce reference maps, so detailed mapping of original infrastructures within maximum 10 hours, but we're talking about best effort here, so even before that. Then the first estimated product that we can produce based on already available satellite imagery is done within 2 hours, very tight. And then we have the delineation map to provide the extent of the event, which is very useful for fires and flood. This can be done in maximum 7 hours. And the grading, the damage assessment within 10. Eventual monitoring is always provided if needed. So if the event is ongoing for multiple days, sometimes even weeks, it depends. We are providing daily or daily products for the user. Our skillful operators and emergency managers are reviewing the requests. They're providing feasibility results for the activations. That includes also the area refinement. As you can see here, a quick example for Jamaica that was a recent activation due to the storm that hit the area. We tend to include all relevant key features such as urban areas or industrial areas, and remove non-relevant areas such as large water bodies, mountain tops if we're talking about flooding events, etc. So for the activation setup, we are relying on ESA's support since they're our provider of the imagery that at the end provides also our own imagery, such as Cosmo. And we are accessing the imagery through platforms that are being connected to our own platform. So we have a lot of automatization that is helping us to be faster. So we can order new taskings and archive imagery with a precise time span, sensor type, resolution. I wanted to just give a little overview of the past activations in Indonesia. As we can see, most of them are earthquakes, but also one tsunami. And on the right, you can see the grading product over one of the areas in the last activation. However, the service is ever evolving and keeping up with the tech's evolution. So we can now have a quick overview of the new products such as damage assessment, which is, as said, grading product provided in maximum 10 hours. And for this occasion, we have chosen the earthquake in Myanmar. It was a high impact earthquake that occurred in March at the magnitude of 7.7. The epicenter was located west of the city, and you can see on the, I don't know if you can see my pointer. When we have received the activation, we had only 30 hours to provide the first products delivered. And this was due to new tasking. So we have to wait for the first imagery to be received from the provider, said ESA. We provide change detection analysis, as you can see on the left. Okay, so my pointer is very sensitive. Change detection analysis, as you can see on the left, the post-event and the pre-event, the damage is evident. We also provide surface rupture details on the maps themselves. And as you can see here, again, damage assessment on the buildings, which was very important for managing the crisis. We have provided 57 areas of interest in total, and in total 96 products. Then for the wildfires, we can provide delineation monitorings throughout the event itself. And here we detect fire fronts as well as active fires. All of the products can be seen on the website itself, but the maps are being delivered to the user directly. Then throughout the days, the fire got smaller and we had less and less active fires and less fire fronts. And that's why we provided at the end a grading analysis for the damage assessment of the area that was suffering the disaster. The burnt area was extensive, and this was only one of the areas within this wildfire in Attica that we have chosen for this presentation. Currently, a new activation is ongoing, which is a wildfire in New Caledonia. And you can see here a presentation from a screenshot from the portal itself, how you can click and turn on and off different layers of the products. And this is the map that we are providing to the users as a geoinformation product. A list of statistics is also available on the portal as a part of additional product called situational reporting, where we sum up all of the products from different areas into one page to give an overview of the activation for the said country. Now we are moving to the flood product. And for this, perfect example was flooding in Italy. Why? Because we have seen the use of multi-sensors using radar imagery that covered more than 3,200 square kilometers to provide more accurate areas that were later on analyzed also with aerial imagery, so optical imagery, after the clouds, after the cloud coverage has lifted. So with Cosmos SkyMed here, we have managed to pinpoint detailed areas and focus later on for further grading products. This was also a massive event. A lot of infrastructure has been hit and the population has suffered. This is a quick overview of the satellite type used, as well as the aerial imagery that was provided with the help of Joint Research Centre from the European Union. We interpolate the information with hydraulic modeling, the information obtained from the radar satellites. We interpolate them with hydraulic modeling and external validation from social media. So to provide enhanced floodings, flood depth and flood velocity maps as well. The latest activation for flood is obviously flood in Sri Lanka, as you can see here. The Kilani Ganga River area presents an extended event, and we have provided delineation products, so flood extent in this case. This is the overview from the portal that is available at the link mentioned at the beginning of my presentation. And here you can see the map that we provide in PDF format, but as well within vectorial files. So a quick overview of the observed event and the potentially impacted population, which is already extensive. I would like to mention also some of the most interesting activations that enabled us to provide particular products for the users, since during volcanic eruptions, optical imagery in this case was not very useful due to dense cloud coverage and smoke coverage. So we have used radar and Cosmos SkyMed of second generation. in volcanic eruption in La Palma, Spain. Here you can see the lava flow from the volcano towards the urban setting. So this was critical for the people to manage, for civil protection to manage this crisis. Thank you for your attention. If there are any questions, I'm happy to reply.
Thank you very much, Nina. Okay, now I can see you finally. So, any quick question now? Yes, there is one. Can somebody bring a microphone there? Should be another microphone around. Yeah. Oh. No.
Okay, thank you for the opportunity to question. My name is Reski from the Amateur Astronomy Association of Jakarta, and I just wondering to you, because the Copernicus EMS is such a worldwide 24/7 operations, right? So in your experience, or maybe in your team internal assessment, how many activations that the team can handle in one time, and maybe you can share with us how you or your team achieve that many activations at the same time. I hope it's clear enough. Thank you.
Yes, it's a very good question. Sometimes we ask ourselves that question as well. How many activations can we handle at the same time? Especially when the event is very disastrous and there is a lot of areas, because sometimes we can have 15 activations, but each activation has just one area. So that is basically like we're dealing with 15 areas, which is very, very doable for the service, nothing too complicated. But when we're dealing with the 35 areas or 57 areas per activation, such as in Myanmar or in Valencia floods, or more recently in Jamaica, that's when it gets tricky and we call for backup. e-GEOS is the leader of the project, but we have many partners. We have 6 partners across Europe. So each company has a team of people dedicated to work during shifts, night shifts, day shifts, weekends, and all the holidays. So that is all. We are just calling for backup, and the service capability is until we ask for help from the European Union themselves. They are, however, separating different types of activations throughout different services. So the emergency management has the rapid mapping, as well as risk and recovery and other services. So I hope this answers your question.
Any other question? Yeah.
Okay, thank you for that. My name is Shanti. I'm from ASEAN International Advocacy. We do a lot of advocacy works for space and satellite. We are not the technical part. We are the advocacy part in terms of space junk, equitable access, and all those things. Just a quick question. With regards to the sustainable green and blue and whatever agenda we have been looking in the last 5 to 10 years, illegal logging is a big issue, and Indonesia today is facing one of the major national disasters because of illegal logging. Can we use satellite to detect how many forests, what are the activities happening there, who is doing the, well, not who, what are the illegal logging taking part in which place, and create an international alert, because if you inform the government of the country, probably the government is actually involving in the illegal logging, so they wouldn't do anything about it. But can this technology play a part in ensuring that our world is actually green, and whatever we are talking about sustainability is actually being supervised and monitored, and there is a 24 eye watch on them? I mean, this is one area we can do fire, we can do flood, we can do all those things. Why can't we watch our forest and see who is doing what there? Thank you.
If I may just add, I mean, it's very connected to this. I mean, with the introduction of EUDR, so the new regulation about deforestation, yeah. So that, you know, from the 1st of January, you cannot import in Europe anything that has been the result of deforestation, okay? This is also something that can be handled with satellites. And in fact, later we will have a presentation by Mario Simaco from that, let's say that Green Ant, they also, actually they started working in Indonesia exactly for that. Now they work also with insurance. He will present his presentation, yeah. But actually, this is an example. So, but maybe Nina can add more from their point of view.
Thank you. I can reply to the technical aspect. We can definitely see illegal logging from the satellite imagery. What the service that I have presented is doing is emergency situations during specific events that have, let's say, a start date and an end date, and are more related to natural disasters. Rarely we're dealing with the events such as concerts or illegal logging. We had these experiences, but this is up to the commission that forwards the request to us. We have provided products for the storm in Europe, and we were asked to show them the direction of the fallen trees. So with very high resolution optical imagery, we can definitely detect it. Now I think this is a high level topic for the strategy in which service will provide this information on a constant basis. I would say that a request can definitely be made, and maybe some wheels can get turning by just sending out the requests for these products.
Thank you. My name is Marco. Myself, I'm country manager in Indonesia for Leonardo Group. Thank you, Nina. I want to replay, maybe in terms of application, the satellite, the technology is only the instrument. It's important that we create the capability and knowledge in the country in terms of ground service, because the satellite can give the information. But if you don't have the center that receives the information, if you don't have the artificial intelligence, the predictive monitoring, and then not apply the verify constant and every day, the area for deforestation or the other volcano, you cannot have any success. So in this case, if you have the imagine after the disaster, you can do many things in terms of help, but you can monitoring the area before you can have predictive. So in this case, Leonardo Group is apply for every technology in terms of satellite, ground service, monitoring, geoinformation, everything, the artificial intelligence. In the defense sector and the civil sector, is the same in the defense sector. No? If you want to anticipate the threat, we need to anticipate the reaction. And then we need to have the quantum technology communication, and then we to reduce the reaction. So in this case, according to me, many countries in South Asia that don't have a budget to create a constellation, we start for the center. And then we, said to say in Indonesian, plan, you arrive to have the capability and knowledge to understand the instrument of technology satellite.
Thank you.
Sorry, let me also add another thing from Leonardo Group capability, in particular for forest monitoring. We have a long-lasting experience on that. So as Marco said, of course, the satellite and the technology is the base to get the capability, but then is the local organization, the local government to develop the service for the various user. But what I can say is that by using SAR and optical data, we have developed a lot of services, especially in Amazonian, since years. We are supporting the local authorities to monitoring the legal deforestation and also illegal activities inside the Amazonian area by providing regular monitoring of the specific area. So, of course, it represents an investment from the country, which believes that it is a strategical infrastructure, strategical asset for the country to monitor and to understand what is happening. But in terms of technology, this is absolutely something available and that can be put in place in a relatively short time.
Thank you very much. I think we move on now. Of course, you know, the discussion can be continued later during the Q&A. So thank you very much, Roberto and Nina, for your presentations from e-GEOS. So now we have the first speaker in person. So Professor Herland Darmawan from Università Gadjah Mada, who will talk about the key role of remote sensing to assess volcanic hazards in Indonesia.
Okay, good afternoon, ladies and gentlemen. I'm Herland Darmawan. I'm from Gadjah Mada University. So let's talk about something hot, volcano. So I mostly use satellite for volcano hazard assessment. As we know now, our Earth has almost thousands active volcano that documented by USGS, and we cannot monitor all of this volcano by geophysical instruments, as it will take some expensive stuff. So we can use satellites to monitor some of the volcano here. And we are currently in Indonesia. We have subduction zone here, and most of the volcano in Indonesia is a composite volcano. So we have something like conical shape, and of course we use satellite to observe this active volcano. And in Indonesia we have 129 active volcanoes. It's almost 30% of the number of the global volcanoes in Indonesia. And we only actively monitor 68 volcanoes in Indonesia because, yeah, as I said before, geophysical instrument is quite expensive. And the rest we can monitor by using satellite observation. So I take some cases. First one is Merapi. This one is the most active volcano in Indonesia. It's located maybe 40 kilometers from my university. And this is the summit of Merapi. You can see some volcanic degassing at the open fissure. This is the drone image. So besides satellites, we can use a drone image. And you can see the rock is very yellow. So the interaction between gases and the rocks can change the rock colors into yellowish colors. And the interaction may cause the rock weakens. Yeah. Weak, and weak, gradually over years. And if we do not monitor this, we call it hydrothermal alteration. Yeah, hydrothermal alteration. So it progressively eat the strength of the rocks gradually, years, and once the magma go to the surface, it can push some of the flanks and may cause collapse like an Krakatau. So one of the factors that may trigger the collapse is hydrothermal alteration. So remote sensing from drone may help to reconstruct the geometry and assess the hazards. And we took some samples, rock, from fresh to fully altered rock to assess how hydrothermal alteration weakens the dome rock. And this is the drone image from 2015 to 2017. You can see the yellowish colors gradually spread at the surface. And you can see this is some fracture, a big fracture here. And you can see that the hydrothermal alteration gradually spreads over times. So we should monitor this. We cannot monitor these processes by using geophysical instrument, but we can monitor this by satellite image or drone image with multispectral analysis. And then we analyze the rock sample by using geochemical analysis and physical rock properties analysis. You can see this one, this is the fresh rock that contains some plagioclase and pyroxene stuff. And when it's altered, there is some gypsum minerals. So it's weak minerals inside the Merapi rocks. And you can see this one, some altered minerals is gradually block the rock pores. Yeah. This is the space usually to transfer some fluids like volcanic gases to come out to the surface. And once it's blocked, it may produce gas overpressure. And suddenly, it may create a sudden phreatic eruption which dominated by gases. It's really difficult to be predicted. That's why we should monitor the alteration. And the side effect is it may weaken the dome rock up to 12 times. Our analysis show that the fresh rock has a rock strength about 140 megapascal, but the fully altered rock is only 11. Yeah. So it's quite dangerous. It's quite dangerous. And then I analyzed by using a factor of safety analysis, and I conclude that this part, this southern part, is weak and potentially collapse. This is the time series of lava dome from 2012, 2015 to 2019, and you can see here this block is collapsed and new dome extrudes. So it's really delineated by this hydrothermal alteration. And we can monitor this activity from the sky, from the satellites, high-resolution satellites, from maybe Sentinel-2 and drone image to analyze the hydrothermal alteration spatial distribution. And the second case I took Anak Krakatau. I think the case of Anak Krakatau in December 2018 is very famous case, and we should monitor the morphological change, because again it's stratovolcano, it's composites. It will gradually rebuild the edifice over years. You can see here, this is a drone image in 2019, maybe months shortly after the flank collapse that triggered tsunami in December 2018. And then we analyzed Sentinel-2 image temporarily with a clean cloud. And you can see here, the crater lake gradually decrease. And it's filled in with the new deposit volcanic materials. And in early 2020, during pandemic, maybe most of the Jakartans people hear some roar in the sky during a pandemic in the midnight, and it possibly Anak Krakatau erupted and produced this large lava flow. So this crater lake now filled in with the very huge lava. So actually this volcano now is rebuilding its edifice. Maybe it will more lava in the next year, more, and then it will make a cone shape. So we validate this satellite image by field work, some pictures during field work, and yeah, you can see here some steam-dominated eruption gradually occur at Anak Krakatau in 2019. And in 2020, we visited Anak Krakatau again, and you can see here some massive lava flow. Maybe the height is about 100 meters. And then we analyzed with Pleiades satellite imageries. We can see more detail about the lava flow structures. So we can really delineate the fractures in the lava flow deposit, and we can analyze that this lava was subjected to compression, extension, and compression regime in this edifice of lava flow, and it's in place at the low slope. At the low slope. So to summarize what happened at Anak Krakatau, we make some conceptual model that this is the condition of crater lake at Anak Krakatau shortly after the flank collapse. There are some sediments or volcano materials after the collapse, and we have some water lake here, but some heat sources still existed, but because the sediment was heated by the maybe dike or magma, it may produce gas. Yeah, it may produce degassing, and then it coalesces and produce some like gas slug. We can gas slug because it's easy to buoyance. It go to the surface and produce this steam-dominated eruption. So the steam-dominated eruption continuously occurred during the late 2019, and between January and February, because the magma possibly ascending, hydrothermal or phreatomagmatic occurs and produce some small volcanic cone. And the magma continuously ascending to the surface, and it will contact with the water in the crater lake, and it may trigger phreatomagmatic eruption. Yeah, phreatomagmatic eruption. It will destroy all the volcanic materials within the below of the crater lake, and then lava flow in place at the Anak Krakatau edifice. So yeah, monitoring of the Anak Krakatau edifice is very, very important. And the third case, we have an active volcano in the north of Sulawesi Island, or Sulawesi Island. We call it the Karangetang volcano, and it's located in Siau Island, in the middle of Siau Island. This island has a population about 70,000. So you can imagine if this volcano suddenly erupt and we should evacuate the people, it will get panic, right? So monitoring this volcano is very, very important. And we conduct a multi-hazard assessment by fully satellite imageries with Sentinel-1, Sentinel-2, and Sentinel-5, and Landsat. So from Landsat, we can detect some thermal anomaly at the summit of the volcano. And we found 3 crises in 2015, 2019, and 2023, in the last decades. We found here this crater has a maximum temperature up to 100 degrees Celsius. And some of the eruption mostly effusive. It mostly produce lava flow, not pyroclastic flow like Merapi. So we map the distribution of the lava flow in the last decade by using Sentinel-2. And you can see this one, there are some deposit area. The first crisis is the activation of the north crater. So actually, Karangetang has 2 craters. The southern crater is more active than the northern, but in 2019, this crater suddenly active. So the magma suddenly moved from the southern to the northern and destroyed this area. There is a village here. There is a village here, and this is the only road to get this village. So this village is isolated, was isolated during this crisis by very thick lava flow. And people cannot cross this lava flow because it's very hot, right? Yes. So this is rarely occur. The activation of the northern crater is rarely occur and suddenly erupted and then changed the hazard zone. And afterward, the magma moved back to the southern from the thermal anomaly. And it moved to the west area. Fortunately, it's only 100 meters, maximum only 1 kilo, but the closest village is about 3 kilo. Yeah, about 3 kilos from the summit. And in 2023, like 2 years ago, it erupted again, and it moved to the south. The lava flow moved to the south area. And then we analyze the deformation by using Sentinel-1 to analyze the deformation of the volcano, the magma movement. And you can see here, before the eruption, the Karangetang edifice mostly doesn't have any displacement, but before shortly the eruption, this part has a red color, means that the edifice of the volcano has increased like almost 5 centimeters. And this is after the eruption. So after the eruption, after lava flow deposit, the edifice a little bit subside, 5 centimeters. And then the volcano of Karangetang edifice increased again up to 5 centimeters, and then it's erupt and decrease again. So during magma ascending, the volcano inflates like 5 centimeters, and then after eruption, it decreases again, and then magma ascending again, inflate again, eruption, decrease again. So it's really helpful. But we analyze cumulative displacement, it shows that the most of Karangetang edifice experience subsidence. So this is a little bit uplift, but in the last 10 years, actually Karangetang experienced subsidence because the lava flow deposit over here is cooling. Yeah, it's cooling and then gradually decrease the elevation. And then we add SO2 analysis by using Sentinel-5. We can see some distribution of SO2 gas at Karangetang during the crisis. Unfortunately, we can only analyze the 2019 and 2023 crisis because before that, I think Sentinel-5 is not yet operate. You can see here some maximum SO2 intensity from Karangetang during the 2019 and 2023 crisis. It emit almost 1.8 kiloton and 1.4 kiloton SO2 gases, and it's mostly distributed to the southwest, northeast, south, and west area of Siau Island. It depends on the wind, the direction of the wind at that time. So sometimes you can use this for flag hazard analysis. So during this Karangetang eruption, maybe the airplane should avoid this area. So from these three cases, based on our research, we can use remote sensing data sets. In this case, we can use drones and combine with satellite observation to analyze the instability and hydrothermal alteration. And we can monitor the morphological change of an active volcano, maybe like Merapi is also important, Krakatau, and others volcano in Indonesia. And we can conduct multi-hazard mapping, because Indonesia has many volcanic islands, and not all is very well monitored. We can use this satellite data set to generate maybe recent hazard zone, such as it at Karangetang. So I think the key role of our remote sensing, especially moderate satellite like Sentinel, is very, very important to us. Thank you very much. So, if you have any question, I'm welcome.
Thank you very much. Are there any questions? Yeah. Okay.
Good afternoon. Thank you very much for your presentation. My name is Jan. I would like to ask about the use of satellites in assessing volcanic hazards. From what I've seen from your slides, for example, except for the sulfur dioxide distribution of Karangetang volcano eruption, I think most of the other examples you provided were collected within a time frame of like months or years, according to the data you provided. And since sometimes when we observe volcano, changes can happen within like days or even hours, has there been any example of capabilities, like satellite capabilities, being employed by the Indonesian Volcanic Agency to assess like future hazards and how to best prepare in the coming days or maybe like a week or so? Maybe that's will be my question.
Yeah. So
thank you very much.
Yeah, thank you. I should, because there are 4 questions. Oh, directly. Thank you very much. May I answer it, Prof. Karnil? May I answer? Yeah. Yeah, because the limitation of satellites has revisiting time, right? And like Sentinel, we cannot, in temporal resolution is quite weak. And but like in Karangetang, for example, the geophysical instrument, there are some geophysical instrument, but not really complete like Merapi, but they have it because it's a densely populated island. But this research can complement some missing information. They not regularly monitor this SO2 degassing because it requires a special instrument like DUAS instrument or something. But we have this Sentinel-5 that can give some complement to the SO2 monitoring, and they have GPS for deformation, but only one, and seismic station maybe 2. So yeah, we can add this technique to integrate with the geophysical instrument. I hope it's answered your question.
Hi, good afternoon. My name is Irfan. I am an offshore explorer. So, continuing his question previously, is it possible to, because me as an offshore explorer, we rely on satellite data like windy.com to monitor weather, because that website feeds off from the satellite as well. It gives us real time whether the storm coming or not. So is it possible for your LSF and deformation analysis based on the Sentinel-5 imagery to build a real time, not real time maybe, or daily interactive website? Like we have hundreds of volcanoes, and like every hour, this Sentinel-5, sorry, will give you imagery, and then you feed off your algorithm to AI, and it helps to give you interactive monitoring of volcanoes.
Yeah.
Thank you.
Thank you. As I said before, that Sentinel has a revisit time. Like Sentinel-1 is about 11 days maybe. So 11 days they visit the same spot, same area. It's actually possible because some people from Leeds University conduct this research. They automatically process the Sentinel-1 to analyze the potential earthquake and potential eruption. But of course, we cannot predict when the earthquake occur or when the exact time of eruption occur. But at least they have tried about it. And they really use this Sentinel-1 to analyze the deformation, the dynamic processes in the lithosphere. And they can get some displacement in some area. They use AI and machine learning stuff, and they monitor it like weekly, not daily, because it has a revisit time, and they monitor not all because it will requires a big server, because one Sentinel radar dataset is about 7 GB, and they process maybe 100,000 satellite imageries globally. So you can visit. Their group is Comets, I think, from UK, from Leeds University, and they create interactive map in the website, so we can see that, for example, in Merapi, you can see that the ground is moving and then subside again and increase again and decrease again, like some pattern stuff, and they also monitor an active fault, so that may produce a big earthquake. But when I joined their Zoom meeting, I challenged about the atmospheric correction in Indonesia. They said it's quite difficult to remove it in Indonesia. But some area they already give a very good result. Okay, thank you.
Okay, thank you. My name is Ru. I'm an independent researcher, and also I'm from UGM actually. So my question is, I kind of missed your last explanation regarding the gas buildup. So, from my understanding, sodium sulfur dioxide is a colorless gas. So I'm assuming that the monitoring is combined with other instruments. Is that correct?
No, it's Sentinel-5 is also may detect this.
So the satellite
distribution of
this
SO2.
can, even if it's okay. So does this have this ever been implemented in other site of gas sites, like maybe in hydrothermal or geothermal sites, where there are particularly dangerous gas buildup that might be hazardous? Yeah, that's basically my question for the other utilities of this satellites, majorly, particularly in toxic and hazardous gas. Thank you.
Yeah. So thank you. Yes, sure. We can monitor the SO2 gas even from human activity. So yeah, we produce some SO2, right? Besides CO2, and there are some research paper comparing the SO2 gas production from volcanoes versus human by using this Sentinel-5 satellite image. Yeah, sure, you can use it.
I just wanted to add to your questions. There is a project called Mount. Mounts
yeah.
that is monitoring unrest from space.
Yeah.
And it is a global volcano monitoring platform. So you can look it up, and okay, it is from Sebastian Vallat.
Yeah, I know this guy. Sebastian Vallat.
I had to look it up. That was why I was not playing with my phone. I was looking for it. There was another question somewhere. Yeah.
So hello, good afternoon everyone. My name is Fajrina, and actually I'm on my first semester on communication studies, so you can say I'm an outsider with no any science or engineering background. But after hearing the explanation about the satellites, it is really expanding my knowledge, and it's actually so amazing to listen about this satellite. And as a communication student, I want to ask, do you have any publication strategy to properly introducing this concept, the concept of this satellite and its main function to capturing the surface of the Earth and capturing any events or any hazard or disasters that happening on the Earth to the public like me with no any science or engineering background? Because after listening to the explanation, it's very interesting, and I think it will be so great to public to hear the explanation about the satellite also. So my main question is, do you have any strategy to properly introducing the concept of this satellite and the main function to our Earth and its benefit to informing about the hazard or disaster that happening in our Earth? Thank you.
Thank you. Yeah. But I appreciate because you are from the communication, right? Yes. Actually, there is some organization, but they are not. I think they are not commercial. They use social media stuff, and they quite active. I cannot mention by one, but some of them, they use this Sentinel analysis, and they only explain the hazard area, not the concept of these satellites, unfortunately, because maybe it's quite difficult to be understand, but their message is we have a real-time satellite that observe our Earth real-time, and we can download it for free to conduct hazard mitigation or small research stuff, and they spread it by using social media like Instagram, TikTok, Twitter, X or Facebook, and they have quite a lot of followers. So yeah, I hope they someday can expand this. I think maybe you can learn some remote sensing stuff, or some remote sensing student can learn communication skill, etc. To explain the concept of this satellite to people. So sometimes it's quite difficult.
Thank you very much. Thank you also for many questions. It's good to have an active discussion. Okay. So thank you, thank you once again for your presentation. And we now move back online. So I hope Mario is connected. So we'll have Mario Eduardo Simmaco. He's the CEO of Green Ant, and he's Italian, but he's actually connecting from Bangkok, I think. So he did not have to, wake up very early to be here. So Mario, are you connected?
Hi everyone. Nice. Very happy to be here today, and thank you so much, Roberto and everyone at the embassy, Giovanni and everyone for inviting me here today. It's indeed it's an honor.
I sit down and I leave you the floor.
Especially after this lineup of speakers and e-GEOS and the colleagues from e-GEOS who I greet. So my name is Mario, and I am the founder and CEO of Green Ant. And so let me go into some slides quickly. So at Green Ant, we built a platform called Desidera, which uses satellite data to forecast natural threats. So I think this connects very well with the conversation that we were having before about monitoring and forecasting natural threats and natural damages. Green Ant, Desidera has a lot of capabilities, including into the field of monitoring and preventing deforestation. And indeed, we have a long experience in Indonesia, and we would like to keep expanding on that side in Indonesia. But this presentation, I will mostly focus on the work that we are doing for preventing the damages of flooding, which indeed are a huge problem for Indonesia and for the whole Southeast Asia, as we have seen with the tragic flooding in Sumatra in the last week. So yes, at Green Ant, we analyze satellite data with AI to anticipate climate risks. Indeed, we can call it a flooding crisis in Southeast Asia. There is an account of more than 80 billion annual damage in the region. More than 5 million people are affected every year, and yet just 5% of the population is insured against flooding. That's a very, very tiny percentage for such a big problem, which shows the vulnerability of the system itself. Indeed, the problem is that today insurance is not sufficiently structured in order to protect people. It's often too costly and oftentimes not able to actually help people when they need the most. And that's why, through Desidera, we are launching the first anticipatory protection for flooding. Thanks to our system, we are able to forecast floods between 3 to 5 days in advance, pay earlier than the flood occurs, not to compensate for damages, but to avoid them to happen, to mitigate them as much as possible. And this allows for prevention of damages up to 70% through efficient preparation. Desidera uses satellite data to build rainfall to flood maps. Essentially, it allows for to build digital twin models of the Earth to quantify the amount of rainfall it takes for a given area to be flooded, and therefore quantify the conditions that will trigger a flood in a given area. And thanks to this, we can simulate the effects of given conditions. That's an essential point of our technology. Indeed, as you might know, historical flooding is no longer an efficient predictor of future flooding. Actually, it's the opposite due to climate change. And that's why we built a digital twin model which allows for simulations of various weather conditions over a given area to simulate what will happen. And then we use our proprietary machine learning algorithms to model past flooding events and therefore find ground truth evidence of flooding in a given area, and therefore being able to improve and calibrate our systems. Thanks to this technology, we can therefore build a rainfall to flood model to forecast the floods rather than to act before rather than afterwards. Our system is therefore builds an insurance flood index, which uses a combination of satellite data. We use mostly radar satellite data from Copernicus, but also optical imagery and rainfall data. Our data mostly come from national weather stations where possible. We also operate in places in which, unfortunately, access to the weather station is not possible, such as Myanmar, but also more commonly available data such as ERA5 or similar ones. And we use our own trained machine learning algorithms to build these digital twin models and calibrate our data, and therefore deliver a dynamic rainfall to flood triggers. Essentially, the system works that these rainfall to flood triggers are the cornerstone of the anticipatory insurance. In the moment our system forecasts that those rainfall to flood triggers associated with a specific location are expected to be exceeded, then it triggers payment 3 days in advance, thus enabling an anticipatory insurance which delivers when the triggers are forecasted to be exceeded rather than when they are actually exceeded. And in doing this, we of course use radar because, as has been said already, the optical tools are of course not sufficiently nuanced in a region such as Southeast Asia due to the presence of clouds. This is, of course, an example from Sumatra, right? So we have extensive experience in using radar satellite data, and thanks to them, of course, we can collect information regardless of the climatic conditions or the clouds created by also by volcanoes, of course, and therefore, this combination of rainfall forecasting as well as post-disaster monitoring allows us to achieve an accuracy up to 95% in forecasting floods. We operate mostly in Southeast Asia, but of course, this technology can be used anywhere in the world. And thanks to this, we are able to jump from parametric insurance to anticipatory parametric insurance. This is an enormous jump into the insurance technology because we have seen, especially in Southeast Asia, especially in the Philippines, but also in Indonesia, how parametric insurance can be a formidable tool to reduce disasters effects, but yet parametric insurance pays after the disasters and therefore is oftentimes not sufficient to to avoid the most of damages, and yet people, although they are compensated, and of course parametric reduces the problem of claims verification and adjustment, yet it is too late. And therefore people can be more insured, but yet not protected. Thanks to this rainfall to flood system and anticipatory insurance, we are able to actually protect people and therefore reduce losses between 50 and 70%, as well as, of course, reduce the cost of insurance because we reduce the loss potential by covering not the expenses of rebuilding or compensating, but the expenses for evacuation, crop securement, etc., etc. The platform works very, very easily. Like people can log into the platform, frame a plot of land, so have an area that is monitored, and automatically it will send early warning alerts and payments to those who are registered through the platform. It can work up to 5 days, but of course in most locations it's up to 3 days in advance. These rainfall to flood triggers can make infrastructure more resilient, as well as communities, and make everybody more aware of the risk related to flooding, but also keep premiums low and accessible. And the point here is that in many communities, especially in the most vulnerable communities, even if there are early warnings, the cost to act is oftentimes too high to be implemented. Let's say if you are a smallholder farmer and you need to decide if to evacuate or not after you received an early warning, the risk of losing everything you have because you evacuated is so high that many people don't take that risk and therefore suffer the consequences of the flood. Rather, if they can receive money beforehand, then that risk is mitigated in advance, and therefore that's a huge incentive to take action for protection. Today, we work a lot with insurance, of course, but we also work with local governments and NGOs, especially NGOs here that are based here in Thailand, but we would love to also work with NGOs in Indonesia to use this solution to help the most vulnerable population that are oftentimes the most vulnerable to floods. And of course, this offers a strategic value proposition also for the market because it allows for innovation. It allows to offer a new and competitive product into the market, as well as offers a huge social impact product, which reduces the inequality of access to data, but also makes sure that the most vulnerable can actually act before disasters strikes. Thank you.
Thank you very much, Mario. Is there any quick question for Mario? Yes, there is one.
Yeah, thank you, grazie. Buonasera, come stai? Sono Alexander. See, it was a very interesting topic. Yes, Alexander, actually I'm from the AI Association, Indonesia. My question is that in these 4 or 5 years, I've been investing in some startups. Looks like you're doing it. And my problem in the agri-tech actually is the last mile between the agri insurance. Yeah, you mentioned a little bit about your solutions. Actually, I worked with Generali at that time, but they moved to India because it's really tough in Indonesia to to create the business model here actually, because we have a very small holders farmers. Yeah, actually I just want to do some brainstorming with you because actually the most critical one is that we are not able to, actually we are able to predict, but it looks like people here, because they have a short orientation, so they don't really care about the prediction for the long terms. Yeah, so it's basically between technology process and people. Actually, the mindset of the people is really difficult, especially for the farmers. So I'm investing since the early stage, like IoT, drone spraying, surveillance, even the feedstocks, fertilizer. Also, we do have a startup in fertilizer. But the most challenging one is the last mile. This we can use your solutions, and then we can offer it as a business model to the government. Thank you. That's it.
Absolutely. Thank you for grazie for the question. Indeed, it's oftentimes the distribution is the most complex way, and every place, every town, every city, every village has its own complexities, right? So we are exploring a number of ways to implement the distribution. So we find solutions for finding the coverage, right? So that's not inherently the issue. Finding ways for distributing is often the most complex thing. We believe that cooperating with local NGOs and local governments is an excellent way to design models that are locally adaptive. But also cooperating with insurtechs that have tools to design embedded insurance solutions is another essential point, because insurance to be distributed should be embedded in existing delivery channels, such as like mobile data platforms, or other super apps that people commonly use for various things. And so happy to brainstorm further on how this can be actually deployed and how the last mile can be reached and achieved. Thank you.
Thank you very much. Okay, so I think we move on. Thank you very much, Mario, for your
Thank you, everyone. And anyways, you have my contact, so happy to continue the conversation.
It's always
Thank
a
you.
pleasure to. And so we proceed to next presentation. Now we have the next two presentations are in person. So first we have engineer Erlangga Ibrahim Fatah from Itera Lampung, so just in front of Jakarta almost. The title is Unveiling a Blind Fault Between Mount Sinabung and Sibayak in North Sumatra, Indonesia, Insights from Integrated Analysis of Seismicity and Satellite Data. So again, integration I think is one of the keywords of today. Yeah.
Thank you, Roberto. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Erlangga. I'm a lecturer from Itera, Geophysical Engineering. This is our latest research, collaborate with BRIN and GHM, or Geological Mitigation and Hazard Institution. We want to identify blind fault that located between Mount Sinabung and Sibayak that correspond to volcanic activity of Sinabung. Why this is urgent to be identified? So Indonesia has a lot of fault that not identified, like Cianjur fault, where the earthquake last year, 2021, make a devastating hazard in Cianjur. So we want to know, is there any possible blind fault located between Mount Sinabung and Sibayak based on seismicity and satellite data? Sinabung is located in North Sumatra, from within Toba Lake or Toba Pulled Apart Basin Complex. And not only Sinabung located at or form in here. There is also Sibayak, and there is two volcano north of Toba Lake. I forgot the name of this volcano. How about the volcano activity of Sinabung? So Sinabung first eruption is in August 2010. Its first eruption, its first activity after dormancy around 400 years ago. After erupting, Sinabung become less active until September 2013 with eruption of phreatic, continue become pyroclastic flow. And also there is a sign of lava flow from 2014 to mid-2015. And then it changed again to volcanic eruption since 2016. The largest eruption of Mount Sinabung recorded in February 2018 and June 2019. So we want to know what is the reason Mount Sinabung changed its behavior from its years using surface deformation from Sentinel-1. So we mapped the surface deformation using Sentinel-1 A and B. There are 1,000 images from orbit ascending and 900 images in orbit descending. So it's like using two eyes to know the deformation in Mount Sinabung. We want to know, is there any behavior or any corresponding behavior of surface deformation with eruption in lava dome. So we extract the displacement of the lava dome of Mount Sinabung from 2014 to 2021. Its maximum displacement, there is a correspond to one large eruptions. There is a 4 phase of these eruptions. However, there is a unique phenomena or unique activity or even in 2018 to 2009 where the eruption occurred. It continues inflate. So the lava dome is continue inflate from February 2018 to June 2019. What is the reason of this phenomena? So we want to know this phenomena from ground activity. So we would like to see the seismicity around Sinabung. We see there are several seismic city type. There are explosion, hybrid, low frequency, VTI, and VTB. In 2018, hybrid and low frequency, there is a lot of activity. However, in 2019, there is less than the 2018 activity. So we want to see the seismicity around that time, determine and determine the location of seismicity, and want to analyze the source of the seismicity. When we determine the hypocenter, it's another interesting part. For 2018 earthquake, there is distributed around Mount Sinabung and Sibayak. This is Sinabung and this is Sibayak. The activity dense around this area. Meanwhile, for June 2019, it's distributed fairly with orientation of northeast. So we want to know what is the reasoning the earthquake become dense around this area. Meanwhile, for the depth of earthquake is around 0 to 5 kilometers beneath the surface. Next, we want to know what is the reason earthquake dense around this area using gravity anomaly from GGM+. What is gravity anomaly GGM+? It was a model, a gravity model that generated from several combined satellites, such as such as GOCE, GRACE, EDM, and using high resolution topography. We found the location of the earthquake is around contrast high anomaly or contrast high to low anomaly that defined as geological features or geological tectonic settings. And next step, we want to know, is there any evidence of fault trace around the area using Sentinel-1? I'm sorry, this is, I'm clustering the earthquake. This is cluster 1, zone 1, around the Monsinabung, zone 2, around the fault plane that has been identified by PVMBG or GVGHM. This is the question area. We want to know why this earthquake happened around here. And this zone 4 located near tectonic earthquake that happened in January 2017. So after we look the Sentinel data, we found that the fringe or phase interferogram Sentinel data look like gravity that has a pattern with orientation of northwest southeast. This is in January, September, October, and December. The density of earthquake occur in October. The fringe also more visible around this time. So we thought this is the fault plane of the blind fault. And so we want to analyze, is there features of tectonic that could be defined from topography. So we analyze the morphological using lineament extraction. This lineament extraction extracted using MSTA method, using also Sentinel data. The red lines is the lineament. Meanwhile, for this part, the blue one is a stream that extracted using DEMNAS with resolution around 8 meters. From this, we have found that alignment that continue and always intersect with a river. Now, we thought and we assume this is the evidence of tectonic activity around the area. Not in this time, but many, many years ago. And so we define the area and check the stream. Is there any clear displacement or shifting of the river? So the largest shift river is found around the seismicity area with shifting 384. northeast orientation. So we thought this is the fault plane of the blind fault. But not only we identify the blind fault using alignment and stream, we also use Sentinel-2 decomposition of red edge. So this method, we want to check the health of vegetation within a fault plane. If there is a fault plane, the vegetation will be more healthy due to mineral can be extracted more easily. So we found the trace of a green area that intersect with a river around this area. So we assume this is also maybe an unidentified blind fault around seismicity area in zone 3. Meanwhile, for the interaction of seismicity around Z3 or blind fault with sinabung activity, so this is the sinabung. I will try to explain it clearly. So I cross-section from this that intersect with Mount Sinabung and zone 3 to Sibayak. This is Sinabung, and this is the blind fault that I identify. This color determine a seismic characteristic or mechanical properties of the rock or lithology around Sinabung and Sibayak. We found below Mount Sinabung there is low velocity VP and high VP VS ratio. This part we identified as a magma chamber, shallow magma chamber. Meanwhile, below this magma chamber there is low ratio VP VS and high VP. This means there is a magma chamber that cooling down and become more dense and more hard. So what is the connection between Sinabung and blind fault? We thought that if magma migration from the magma push the rock that has been cooling down, it will be make surrounding rock more tense or more pressure around this area, and it will make or generate a slip to the rock and reactivate the blind fault. This is how we identified blind fault using satellite and seismicity data. Maybe like that. Thank you.
Can you go back?
Yeah.
So can you show what kind of movement is along the fault?
Okay. For the movement of the fault, we assume it's a strike slip with right lateral shift. So this is move right, and
almost horizontal.
Yes, yes, it's almost horizontal because the seismicity is almost vertical. Thank you. Okay.
Hi, my name is Irfan. I am an offshore explorer. If you're certain, what is the next step until you can name this fault Erlangga, for example?
Okay.
Because this is unidentified now.
Thank you. The next step is we have to introduce this blind fault to Pusgen. Pusgen is a pusat gempa nasional. This introduction has how I can say yeah, the database of the fault. So they must give a name, not me. Thank you. Okay.
My name is Amri. I am a seismic consultant. My question is it possible to calculate or make average from deformation for deformation state at the first, and also from seismic signal at the first event until the big disaster, so the people can run away from the disaster.
Okay.
Yeah. So if you have any average time from first in Indonesia, it takes in how much time, how much days, or from hours to how much days?
Okay. Okay, thank you.
Do you get? Okay. So.
To identify how much time the earthquake can be make. Yes. Oh, on the first deformation until the largest earthquake. I think it's hard because first deformation always from slip of the rock. Slip of the rock means the first earthquake, right? So it's hard to determine like that. From seismology, we sometimes using seismic hazard or probability seismic hazard analysis to determine which area will more vulnerable and will be more affected by the earthquake. We cannot generate how much time from the first deformation or the first earthquake to the largest one. We cannot predict that.
My name is Dinda Triananda. I'm a first semester mechanical engineering student. I would like to ask if can Sentinel-1 deformation data be integrated with UAV-based LiDAR, UAV-based LiDAR terrain models for volcanic hazard monitoring, specifically all the existing workflows or research efforts that fuse wide area SAR deformation signals with high resolution LiDAR dam updates to improve early warning accuracy for dome growth, slope instability, or pre-eruption ground changes. Thank you.
Can you repeat the question, please? I forget the
LiDAR?
question. Yeah. Yeah, you can I see your question?
In Indonesian?
Yeah.
Oh. I wonder, can Sentinel-1 deformation data can be integrated with UAV-based LiDAR terrain models for volcanic hazard monitoring, specifically all their existing workflows or research efforts that fuse wide area SAR deformation signals with high-resolution LiDAR dam updates to improve early warning accuracy for dome growth, slope instability, or pre-eruption ground changes.
Okay.
Thank you.
Yeah. Thank you. Is there any possible sending data to UAV or high dam topography, right? Yes, there's a possible combination to that. Sentinel can generate the topography also. If you have several sentinel data, you can upgrade the topography. And then you can also calculate the slope, instability of the topography with the amplitude or a decibel of sentinel data. You can use that for identify the possibility of landslide. Yeah.
Just a curiosity, you said that the volcano was previously inactive for 400 years at least, yeah. But it was already considered active before this eruption, okay.
Yeah.
But was it monitored?
Yes, monitored.
Ah, okay. So
Monitored.
before even the first eruption, there was some seismometer?
No.
No, okay.
No seismometer. So before the eruption on 2010, there is no seismometer located.
Okay.
By PVMD.
And then another question is, do you or someone else make any use of volcanic tremor?
Volcanic tremor in Sinabung, there is someone use, but it's not a published work.
Okay. Thank you. Okay, I'm interested in that. Okay, thank you very much. So thank you, Erlanga. So we move on to the last presentation by Dr. Iqbal Pututashidik from Universitas Indonesia. So he's the closest. He had to travel less than the others. So geohazard monitoring from space using ESPAS INSAR technology. Please, the floor is yours.
Assalamualaikum and good afternoon, everyone. I hope the last, not the least, right? So let me introduce my name. My name is Iqbal Putut Ashidik. So actually, Ashidik not separated, actually. Yeah, but you can call me Iqbal anyway. So it's a hard pronunciation sometimes. So yeah, you can call me Iqbal. So this is basically a work of research team that we've established in our university. The work is formed by me, myself, and also Professor Muhammad Dimyati, and also Professor Romatro. And we also have some help from our undergraduate students in the way. So yeah, this is actually a work of a research team. So I think it's rather different between the previous presenter, because you might see geohazard terms might be specific, but in this case, geohazard is related with the surface deformation identification. And in some cases, it's also related with the uplifting or subsidence. So perhaps it's rather specific in that area. So I think I'd like to also give my appreciation to Professor Roberto Carniel, because he actually invited me, and I'm very grateful to meet you here in the session. In this opportunity, I would like also to introduce our department before I go to the substantial part of our presentations, because anyway, this is the networking session as well, right? So might as well to introduce our department. Perhaps you've just heard for the first time. I don't know. But anyway, perhaps you also heard our university, Universitas Indonesia, which is actually now has 14 faculties, 1 vocational program, and 2 schools. And we are located in 2 campuses. We have 2 campuses. One in Jakarta, nearby this location, actually in Salemba, and the other one in Depok. Perhaps you've been there before. And this is actually how to access, anyway, if you've never been there. So I would like to, introduce our department. We are geography department, so I'm a geographer basically, and the geography department is under the Faculty of Mathematics and Natural Science in our university. We currently have 3 study programs: undergraduate or S1, master program, and also the doctoral program. We're currently in the same ranking as the geography faculty in Gajah Mada University, where Professor Henlan from. This is the institutional structure of our department. I myself is one of the head of the undergraduate program actually, so might as well to introduce our department as and our study program. And in our department we have 3 specialization group, if you may say. So geography is very much related with the physical aspect of the earth, social aspect of the earth, or anthropogenic, and also we have expertise from the technological side or geospatial technology. You may say GIS, remote sensing. This is actually where I belong, the GIS and remote sensing expertise. And under this specialization group, we also have 5 research cluster. I will introduce you to our research cluster. This is actually, okay. This is our research cluster. As you may see, although we are in the Faculty of Mathematics and Science, we also have some cluster with handling social issues or social aspect of geography, like, or you may call this as human geography. So we have social, economic, spatial transformation, also political ecology. But most of the clusters are very much related with the tropical landscape dynamics, which is the physical geography, and the technological side of the subject. Actually, this is my cluster, spatial modeling, mostly handling algorithm. We're trying to develop some algorithm. We're trying to analyze the interrelation between physical aspects, and basically we would like to know how the geographic phenomena works in the field, because sometimes the geography phenomena is very complex, and we would like to understand, especially what I will deliver to you today, which is the geohazard or geohazard modeling. So furthermore, this is the area of our research. So you may see some of the, this is actually from the Scopus, the number of our publication, and you can see the highlighted topics that we mostly produce. It's related with the technological side, remote sensing, and we would like to also the issue in land use, land cover changes, something like that. So this is basically who we are, right? So move on to the substantial part of our presentation. As you have seen on the title, geohazard monitoring using SBIS INSAR. So we'd like to implement the remote sensing technology, which is here, the Sentinel-1, or the radar. The radar application, or the active remote sensing, to monitor some activity in the field. What kind of activity? You can see here landslides, land cover, land use changes, which can be monitored by the surface deformation, right? So I put geohazard challenge in Indonesia in this slide. So we know that there are so many potential hazards in Indonesia. This country is basically a disaster lab, right? So one of them is landslide, and it still remains one of the Indonesia deadliest hazard, right? And then also we have earthquakes, we have subsidence in major cities like Jakarta, Semarang, also Bandung, and Yogyakarta. And also, the geohazards like earthquake, sometimes forming or changing the form of the surface, right? So I think based on that concept, we also can monitor some activities based on the formation. So that's the idea. So, but we know that the traditional ground-based monitoring cannot provide continuous, wide area, and timely information across the Indonesian complex terrain. So one of the participants also mentioned, can we do it near real time, something like that. So, yeah. So I think that's where the satellite technology take place or have role at, right? Because the satellite remote sense or satellite data, yeah, some of them have high temporal resolution, like every day. For instance, MODIS satellite, MODIS sensor, every day, 24 hours, you will get new image, right? With Sentinel, perhaps 10 to 11 days. With Sentinel-2, 5 days, a narrow temporal resolution, right? So yeah, we're trying to implement this technology to monitor our Earth, right? So you may see in this terminology in the title, SBAS INSAR or INSAR. Perhaps you've known also the interferometry SAR. Why is this helpful? Why we need this? Because because first the implementation of SAR is because the technology is not affected by the climate, clouds, night or day, as Professor Karnel have been mentioned earlier in this session. So we like to use the technology to monitor our Earth. And also, if we would like to monitor the deformation sometimes happen quickly and in a small scale, like millimeters or centimeters. So we need something that can detect those scale. And the INSAR can do that, right? Because, yeah, the higher spatial resolution and also the higher temporal resolution. So it can monitor very precise, not too precise, but okay. And then we can get some detailed results from the data. So here, why we use SBAS INSAR? Because we need to monitor this Earth in a very high scale, right? All right. So, as I said before, the work is based on our previous studies with our students, and here I try to bring 4 of the study cases, which is located in Sukabumi, West Java, Cianjur, Yogyakarta, and Pacitan. As you may see here, some of the, well, almost all of them is very much related to the works of surface deformation identification, something like that. So we'd like to identify the land subsidence. We'd like to know the land subsidence identification. We would like to correlating surface deformation, something like that. So every work is very much related to the surface deformation. So this is actually highlighting the use of the SAR data. The use of the SAR data, which is to monitor the deformation or surface deformation, which is can be classified as 2, which is its uplift or subsidence, right? This is the workflow from those study cases. I don't know if you can see it clearly or not, but all of them almost have similar data, which is the SBAS or the LIXAR. You can see here SBAS, you can see here SBAS, so almost all of them using SBAS, right? So yeah, why SBAS? So this is, before we go to the SBAS workflow, I would like to, just give you some brief information about the INSAR or interferometry SAR. Actually, this is a rather difficult terms, since also the audience is very various, they have various backgrounds, so I try my best to make it simple, you know. This is art for me as well. So basically, with the interferometry data, you need data from 2 satellites in different time, but in the same location. So we know this is in the same location, but collected in different times, right? So you will see master acquisition and also slave acquisition. This is in different time. So different time, but the same location. Why do that? Because we would like to know the different in terms of phase. The phase different, you know. This is we call interferometry, the different acquisition between 2 periods. And why we use SBIS? So because previously, before SBIS, we only can use two data to create one interferometry. But by using SBIS, we can use more temporal data to create more interferometry, to have more results. Basically like that. So the SBIS workflow here help us to gather more data from different periods, right? But when we are using data from different periods, we need to be careful here, because sometimes the connection or the position is too far between the first period and the second period, or the acquisition period is too far. So the interferometry is, well, we can call it, it's not good, it's not stable, because the period between those 2 data is very far, right? So yeah, to apply this workflow, we also need to be careful. All right, so the process of creating interferogram by those 2 data from different period is a very complex computational approach. So with the help of LIXAR and also SBIS from Leeds University, they actually built this portal. I don't know, maybe Professor Herlan mentioned before, team from Leeds University. So I think this is the products, right? So they already help us to create some interferogram. So they already process it for us, pre-process for us, and then we just collect the interferogram, right? So they help us to pre-process the raw data, right? That's a simple way, I think, to explain what is this, right? Okay, and then, yeah, this is the workflow. Basically, the output is the velocity. The velocity is, you know, the rate of deformations, like how millimeter per year or centimeter per year, something like that, right? So we trying to use this data, and then we process the data in 4 different locations. So this is the result from Sukabumi. You can see some good coherence in the red area, but mostly not good. So we can say this in the green color is not the data is not reliable, because the coherence is so low, right? Happen as well in Cianjur. The coherence is so low, dominantly. But we can see some of the area with white pixels. That's the good coherence. Why is that? Because this is actually very densely vegetated area. That's why. That's why the LIXAR is not good. Yeah, we try to examine as well. So based on different spatial settings of the area, right? Anyway, so this is Sukabumi. The results from Sukabumi, you can see the velocity here. Basically, we can measure the rate of deformation, right? The rate of deformation. So we try to correlate the rate of deformation with the landslide location and also the slope degree. So basically here we find something interesting, that landslide is very related to uplift in 16 to 35 degree slope. And also landslide is sometimes also very related with subsidence in 8 to 16 degree slope. So you can see the result from here. Also in Cianjur, we can see some statistical analysis here that the correlation between deformation and landslide is 0.6. So I think it's satisfying for the correlation analysis, right? So yeah, we can say that there is a correlation between deformation and landslide location. Results from Yogyakarta, it's you can see some of the pixels showing not good coherence, especially here, but we see some good coherence in the spreading in the all over area. This is the city of Yogyakarta, and we can see the rate of subsidence are mostly high in this southern part of Yogyakarta city, right? Results from Pacitan, basically we would like to also relate it with the distribution of landslide. You can see some of the velocity here. This figure is we can detect the displacement of landslide in some area with and then we overlay the landslide zonation with velocity with the pixel from the SBIS analysis, right? From those results, we have some remarks. First, this is what we found, that low coherence and vegetation decorrelation are being seen, especially in Pacitan and Cianjur. Yeah, that's why this is actually the perhaps the limitation of the LIXAR and LIC SBIS. When the area is so heavily vegetated, then we have some limitation, right? Related with the spatial resolution, also the LIC SBIS and LIXAR only produce data at 100 pixel scale, so it's not too accurate, right? The resolution is medium resolution, 100 pixel. 100 meter in pixel, all right. And then, we need some ground data for validation, right? Right, okay. I think that is all. Thank you very much, everyone, for listening. I have a nice break, guys, yeah.
The good thing is that you found an application of deforestation. If you deforest, then you get better, better results. No, don't do that. It was a joke. Okay, thank you very much. Any question? You are tired? Okay, so we are running a bit late, but we can have now a general discussion. Actually, I got also many questions from, let's say, from the people when they register. Maybe we can all sit down there so that we, yeah. And of course, also the online participants, if they are still awake, because they woke up early in Italy, and so if they want to, of course, to participate and answer some questions. There were many questions, many questions also like superimposed, but there were many questions about natural hazards, for example, things that people would like to, to see, how we can apply, for example, sea level changing. Well, in general, risk mitigation products, which also, Mario talked about that. Disaster monitoring and response, resilience in coastal areas, which is also, and landslides, national disaster management, real-time decision-making, flooding, of course, which is very actual, unfortunately. And, but actually one thing that also came out of the discussion here, the questions, is actually the last step, how do you communicate these results to the government first and to the general public at the end? Because of course, for me, a very impressive example is the case of Aceh tsunami in 2004, where people died in Somalia, where, many hours later, all the world was talking about this tsunami, and evidently the communication did not arrive, so people still died in Somalia. So how do you think, we can better this communication flow of data? Yeah.
So this, in my opinion, disaster response is about communication from all sectors, right? So, as scientists, we have some technical language that people sometimes do not understand, and only the community understand these words, and we have to interpret our expertise to government and to people that, oh, this area is dangerous, oh, this, you should evacuate immediately and stuff. Yeah, we need some people that's maybe expertise in the communication, communication during disaster. So it's crucial. I think we have one person, I forget his name, from PNPB. He's we have one actually from PNPB, but he passed away. Sutopo. He is a good, he's person in charge to communicate all disaster Indonesia, and he's good in interpret all scientific language from very technical to general people, so people will understand and people will follow him. And now I think it's difficult to replace his expertise. Maybe the young generation can follow his expertise, because it's quite technical, because we have, like me, for example, we have a lot of expertise words that should be interpreted to general people, and maybe it's not my task. My task is to interpret that this area is hazard or not, this time is hazard, you should evacuate or not. It's the expertise from communication people, I think, to interpret this.
Thank you. Yeah, and I don't know if the speakers online have something to do, so to say, maybe Mario connected to, because you are maybe the most involved in this last step, let's say, of communication.
Yes, no, thank you for sharing this. Indeed, the last mile of communication is indeed among the most difficult, if not the most difficult part. So on our side, what we do that we believe to be very, very relevant for this are two things. on one end, we provide very localized early warnings, right? Because if you provide an early warning mentioning a whole area, a whole region, like, I don't know, there will be flooding in a large region, then that doesn't necessarily alarm people, because people tend to be always thinking, well, probably it's not me, right? Or it's a general thing. And instead going house by house, that can really change the perception, and it's super relevant. And second thing, and this applies to everyone, regardless, right? So from the smallholder farmers to the SMEs, etc., providing capital to de-risk the evacuation is essential. With no capital, there is no evacuation, because the risk of suffering damage, even if the flood then is less impactful than forecasted, is too high. Or it's simply impossible because people don't have the resources to fund a structural evacuation. However, then there is a communication point, right? And this goes through channels. The channels are essential, but also the language used into this. And on our side, we usually work with local NGOs, local governments to understand what to say and how. But this is really among the most difficult things, together with planning the evacuation, right? Because even if you have 2-3 days in advance, that's usually not enough. So a structured plan should be something very well defined. I was speaking with some representatives from Japan, and they were telling me that not for flooding, for other natural disasters, they have very, very structured plans. But yet, when they give an early warning, people do not act, because usually they panic. And although they are trained to do specific actions to protect themselves and those who are around them, they do not do because they panic. So there are a number of things that need to be thought through very well before to make anticipatory action and early response effective. And there are various aspects, and of course we'll be very happy to work with anyone interested in this to build more resilient communities.
Okay, thank you. One other series of questions were related to let's say how what should I study, to start working with these things. So maybe we can make Nina talk about this, because she how did you, so what kind of career, what kind of engineering or other, of course, I am a strange beast, for example. I started by studying computer science, and I ended up doing volcano seismology. So sometimes it's difficult to say, but just to, if you can, in Italy, how, because how, what kind of careers can be, followed to then, arrive at a stage where you process satellite data, or work, for example, for a company similar to e-GEOS, for example.
Yes, to be involved with the European space projects, you can definitely study engineering of all sorts, but as well as geophysics. That's what I did. My focus and specialization was risk maps for cultural heritage. So I have combined my two passions, cartography and archaeological sites and cultural heritage. And as Italy is very famous for it, it was inevitable to be a part of my education. However, these fields are very interdisciplinary, So I'm sure that in all sorts of courses, university courses, there are topics that involve working with remote sensing. So definitely natural sciences. That would be my my answer. It can be a specialization. It doesn't have to be the whole bachelor, master's, and PhD. But it also depends on the capacity of each and every one of us.
Okay, thank you. Talking about well, there is one question that is about safety. So as more satellites keep going into orbit, should ordinary people actually be worried about space debris, or is the problem often overstated? Maybe you can. How many satellites did actually crash in the last years? I think it's overstated. I mean, I always say, even when we talk about, natural hazards, volcanic eruption, aren't you scared to, to go close to a volcano? I mean, I always say, aren't you scared to take a highway? Because it's much, much more risky, So sometimes people have, kind of distorted perception of those hazards. This is also something that in communication should be very, very. Another thing is about AI, the use of AI. So how do you think that AI can change this kind of processing? Of course, Mario is the the like the automatic choice for this answer, but maybe we first hear.
I'm sorry. I just wanted to compliment for the question before this, because I guess there is a lot of enthusiasts now in the public and following us. Usually the space debris is guided to Point Nemo in the sea, in the ocean, and the rest of the debris burns up in the atmosphere. So just perhaps it's interesting to underline this aspect of safety before we move on.
Well, about AI, yeah, I think it's not available right now. The development of AI, we see everywhere, and then the important things I think to this approach or to use AI is we have enough information about the inputs, right? The input should be trustable, and then anything good in the inputs should be giving the valid output as well, right? So yeah, I think we in Indonesia, I think there are so many reliable sources of data. I think it's already there, and it's now up to us how to use them very well. How to use the AI as well. It's up to us to choose any kinds of data, especially that very related to our objectives, and as long as we trusted the source of the information, I think yeah, AI should be also promising for us, because yeah, it's now inevitable. Like it or not, we have to face it, right? So I think that's my opinion. Sorry.
I don't have an opinion. Yeah, I think I may escalate our interpretation on something, so it make the processing stuff faster. And like me, I use AI machine learning to do quick classification of volcano deposit. Before I manually digitize, like take minutes or something. Now just use machine learning stuff, supervised classification, just like minutes running. It's very quick, but as a human, we should check the quality of the machine learning stuff or AI. Yeah, it may escalate the processing, but we should take care the interpretation of the AI and the quality. Yeah.
Actually, I published recently, actually 2 versions. Now there is a very recent book chapter about the applications of artificial intelligence in volcano monitoring. So if anybody is interested, just send me an email and I can send you a PDF. Yeah, and now I think we can finish with the question that I liked. So looking into the future, so if you had to choose one major global problem that European satellite technology will solve in the next 20 years, what would it be and why? So while you think, there was another question. Do you have contact or collaboration with Geocom or GFZ in Potsdam? Maybe it was you asking this question. No, I must clarify one thing. Okay, so of course this event is organized by Italian embassy. Italy is very strongly participating in these satellites, but of course we are part of the European Space Agency, and we strongly collaborate. So no, at this point, basically no satellite or can be done by a single country, yeah, and by a single research group. So it is always, there are maybe the leaders, but then there is a lot of collaborators. For example, even on this satellite, GFZ is collaborating, so it's part of the Copernicus program. So Europe is really working together. So this, I think, is an important point. And so now you had the time to think about the big question. So how do you see in the next 20 years, or what maybe what the problems that can be solved with satellites or using satellite data, or where do you see?
Yeah, in my opinion, actually our Earth now evolve very quickly because we are in an anthropogenic session, whereas humans influence many sectors of Earth surfaces. So, yeah, satellite technology may play very crucial role, and we have now AI and machine learning to escalate the processing stuff, interpretation, and some groups publish the result already in a website, so we can just make a very, very quick map and interpretation. So this technology will help human very much in the next maybe 20 years. And I'm happy that this mission maybe will extend up to 2030s, the Sentinel data sets. And I think European Space Agency, I hope, will extend with another sensors to monitor the dynamic of lithosphere and the dynamic of atmosphere, because it's very crucial for us, for human.
What do you see in the future?
Okay, thank you. In volcanic hazard, Indonesia has a lot of volcanoes. There are 127. Currently, 27 or 32 volcanoes that actively monitored by PVMBG or CVGHAB with instrumentation around that volcanoes. However, there are a lot of volcanoes that
cannot be touched because dense vegetations or there are no access to that volcanoes like Karangeta. It's far away from people with Sentinel or satellite. It become more easily to monitor the volcanic activity. And I hope when the Sentinel or satellite interval time become more shortly, it will be, the data will be more dense, and it will be make analysis of volcanic activity more accurate. I hope it will be achieved into the in year early.
So as a geographer, we always interest in the interrelationship between human and environment. So as far as the topics goes, we would like to know about that. We are so interested on how the geographical phenomena works. Like for instance, the Sustainable Development Goals. I think every part of the goals it's important, right? So the satellite image can help us to understand the process. And now we have so many levels of accuracy, ranging from the regional, national scales to very high resolution data. So I think there should be a helpful way to understand how the Earth works, how the interrelation between human and the environmental works. In my cases, right? Specifically for Indonesia, we will face 2020-45, which is the bonus demographic, as you heard, and I think that's one of the important issues on how we can have some simulation from now where we are in the next 20 years, for example, how our country doing in terms of every aspects like social, economics, and also the environmental aspects. So yeah, as far as it goes, the satellite can very helpful in every way. So yeah, I think that's my perception.
I don't know if Roberto is still connected or not, or maybe Nina and Mario can give the last words, from looking at the future and closing the event. Mario? Just, how do we see, the future evolution of the use of satellite data? New applications, or how can be better?
I see Claudio raised his hand, so please, Claudio, go ahead.
Yep. There was another.
I think you're muted.
Thank you. So I would like maybe to show the strategy, the commercial strategy of Leonardo, that obviously have a view for the future, because Roberto and starting for this space, they say all the list of satellite. Today is impossible for one country to have different satellite. The satellite is only the instrument, but the payload in terms of radar, optical, atomic clock, everything. So the strategy of Leonardo is to apply the service, because there is many satellites with different application. And then if you want to check the atmosphere, volcan, tsunami, disaster recovery, defense, it's impossible that one country have a budget to cover overall. Then obviously it's important that the country try to arrange the service, the ground service to receive the communication. The satellite is not enough. In Italy, we have the big center, and then we have also now the center that receive the acoustic water. So the submarine or the sonobuoy receive the acoustic water, and they identify if you have some problem underwater. Also, there is the radar, Matera. Also, there is a drone. Also, there is the cyber threat intelligence that cover every application, WhatsApp, Instagram, and maybe someone take a picture, and the picture there is some strange situation in terms of volcano or waterfall or mining, I don't know. So according to me, for monitoring, real monitoring, we need to apply the ground service and to receive the service for satellite, radar, cyber threat intelligence, acoustic sonar, drone, everything. In this case, you have the capability to cover every threat, civil and defense market. This is the future. And then also, we study to apply the quantum communication technology, because the timing is important in terms of reaction. Because obviously you can arrange the predictive monitoring, but sometimes it's not possible. Not possible for budget, not possible for timing. And then it's very important the reaction. In the reaction, we have also the artificial intelligence that simulated the disaster recovery. And then in terms of the asset and the capability of country, you can apply immediately the reaction. If you have a helicopter, if you have some other device that you can use for help. This is the future, and this is the vision of Leonardo.
Thank you very much. So I think it's time to move to Adef. Yeah.
I'm really impressed by you, Roberto, to bring this ecosystem. I've been like here. Oh, it's okay. I've been like here for. Okay, I've been like here for 4 years actually doing a startup ecosystem, and I think this year, early of this year, because I'm part also of the Association Venture Capital in Indonesia, investor is not pretty what do you call it? Secure about the founders of AI startup Indonesia. So they are not willing to spend to Indonesian founder doing AI startup because they cannot compete globally. So satellite, I think you need to compete globally. It cannot be only local. So I think this is a very good chance, because I met actually several, I heard from the before questions about startups in satellite. Anne is one of the best women here doing satellite actually. He's in Bali. Yeah, he's been to NASA and so on. But looking in different way, like making like education for kids, you know, T-shirts. So you can be also, I mean, become the porte-parole of a satellite, but not only in technical side. Yeah. But again, we don't have any ecosystem yet. Actually, I'm inviting, there is a director from BRIN. He is able to support 2 or 3 startup satellites from Indonesia. But at the end, it's not sustained, because the fund, it's stopped. I mean, you need a lot of funds, you know, for this kind of activities. The same as all deep techs, yeah. Can be satellite, or we are doing also promoting defense industry, you know, like armored vehicle, drones. We are doing drones. But the challenge, then I close, we receive 1,000 orders from agriculture, yeah, drones for spraying. But who's going to pay these 1,000 products? So I think we need to learn from Italy, as you have Romagna Valley. I've been spending a lot of half of my year, my age actually in Italy, you have a Romagna Valley, a very open ecosystem where Ducati or Lamborghini, Pagani, everything can work together in one ecosystem. Yeah, no matter what is the level of your product, but actually the supporting the SMEs behind that brand is very much how do you call it? Very much strong, and they are collaborating each other. So we don't have that yet. I mean, when I built drones in Jogja at the time, I still have to buy from Surabaya. I have to import from Bandung. I need to buy from, and then the cost is very. I mean, cannot be supported by having a drone imported from China, for instance. So. We have a purchase order 1,000 drones, but we don't know how we can fulfill it, we can deliver it. Because the government will not give the money in front. And you cannot just go to the bank because we don't have any experience, long time experience before, and we don't have any assets to be as a collateral. So I think as to be a manufacturing industry, especially deep tech industry, this is a very good initiation, but I think in the long term there will be more what do you call it, up and down, also value of debt and so on, that we need to be got support from the government, investors, corporates, I mean embassies, startups, and also academia, universities. So pentahelix ecosystem. Thank you so much, Roberto. I really appreciate it.
Thank you very much. Now, I was looking at you, and now I'm like the fault. I'm blind because the light is on the back was terrible. Okay, so thank you very much, everybody. The speakers first, also these speakers. Well, they don't see me in front. Okay, so the online speakers, the speakers in presence for being here, and also, of course, thank you to the participants, because it was not like a sterile, just talks and talks. It was a real discussion. So I hope that this is, the start of something that can evolve with time. So this is also a networking event. So, and of course you cannot have a networking event without eating and drink something. So now we will enjoy some Italian food from Sale restaurant. And in the meanwhile, while you grab your food and drink, you can also have a look on the walls. There is this exhibition about love, but love in the sense of love for sports. Okay, thank you very much, and see you next time.